This is Stephanie from statisticshowto.com. In this video I'm going to show you a hypothesis testing example. I'm going to be showing you a one-tailed z-test. Principal at certain school claims the students in his school are above average intelligence. A random sample of 30 students shows they have a mean IQ score of 112, and we want to know if there's sufficient evidence to support the principal's claim. Well, the first step is to write the null and alternate hypotheses. If you're not familiar with doing this, you may want to check out my previous video on how to state the null hypothesis. So our null hypothesis, that's H sub 0, is the accepted fact. Well, the mean population IQ is 100. This is our accepted fact. So the mean, mu, is equal to 100. Now the principal's claim, this is our alternate hypothesis, is that the mean IQ score is greater than 100. He's claiming the students in his school are above average intelligence. So H sub 1 is that the mean mu is greater than 100. So I've stated my hypothesis. The next thing I want to do is choose an alpha level. Sometimes you're given an alpha level in the question. If you're not given an alpha level, go with the standard 0.05. Now what does this mean? Well, if you have a standard normal distribution, the 0.05, our alpha level, is 5%. And this is a one-tailed test. We've got the mean, mu, in the center, it's 100. And 5% of this curve is going to be roughly this area here. I'm going to look up this alpha level of 5% in a z-table because I want to know what is this z-score right here. What is the z-score on the boundary of this 5%? Well, if this is 5%, then the rest of this area must equal 95%. And I'm going to look the z-score up in a right-hand z-table, which gives me scores to the right of the mean. It won't give me this area here. This is 50%. So if this is 50%, this area must be 45% because 50 plus 45 is 95. So I'm going to look up 45% in the z-table. Now I don't know my z-score, so what I'm going to do is look up 45% in the center of the table. 45% is 0.45 as a decimal. This is 1.64 and this is 1.645. So it looks like 0.5 is going to be bang in the center, so that's 1.645. So now I know the z-score that's at the edge of my rejection region. What I want to do is calculate another z-score using the z-test, and if my test falls into this rejection region, it means we can reject the null hypothesis. In order to figure out that z-score, I'm going to use this formula, z equals x bar. That's my sample mean minus mu of 0, my population mean, all over the standard deviation divided by the square root of n, that's my sample size. All I need to do is plug in the figures that I'm given from the question. My sample mean, the average score of students, was given as 112. Population mean, average IQ score is 100. Standard deviation, 15, and that's divided by the square root of the sample size. There were 30 students. And I'm going to figure this out on a calculator. I get 4.56. So my question becomes, is the z-score I calculated with this formula greater than the z-score I calculated with my alpha level? And the answer, yes, it does fall into the rejection region because 4.56 is greater than 1.645. So I can reject the null hypothesis, which leaves me to accept the alternate hypothesis that yes, these students are above average intelligence. In my next video, I will show you a two-tailed z-test. Check us out at statisticshowto.com for more videos and articles on everything elementary statistics.